this is the same workflow as you did yesterday, right?
Yeah.
Okay, because I recorded that.
Now I'm adjusting the thumbs. So you can see the tornado damage back behind me. Some broken tree branches, sheet metal in the trees as well. Just behind the church has some pretty substantial roof damage on it. And this is the gravity wave sensor that we mounted on the sign right on the south edge of the church. A stop sign was flattened directly next to it from southerly inflow streaming into the tornado. The church was damaged as the tornado passed by. So we definitely sampled tornado vortex with the northernmost gravity wave sensor. We deployed 3 up and down the road here from Petrie off to the north, 3 lined straight up. Ideally, I try to get those in a triangle configuration, but the northernmost gravity wave sensor sustained a direct hit on this tornado. And you can see some of the tree damage here as well. Thankfully, the church is okay, but it does have roof damage as well to it. Good morning, everybody. This is a live emergency briefing as we have yet another enhanced risk across a large swath of the southeastern U.S. This is the video that we collected yesterday, and we did deploy a line of gravity wave sensors north and south from the Petrie, Alabama area. The northernmost gravity wave sensors sustained a direct hit from a tornado that came through. It was a grungy tornado. We were looking off to the north with the Dominator drone, and you could definitely see exactly where that tornado was. LCLs were still quite low this early in the outbreak during the late morning hours as it was over the southeastern Alabama area. Numerous tornadoes were reported yesterday, quite a historic day for severe weather, including some strong tornadoes that happened over southeastern Georgia into southeastern South Carolina as well, crossing the Savannah River. Definitely looked like some funneling that was happening as well. Some funneling of that wind right up the Savannah River Valley. Looks like the video here is definitely having some issues, certainly. But today is the 3rd enhanced risk in a row today, and that is across a large swath of the southeastern U.S., eastern Tennessee, all the way down through eastern Alabama, through a large section of Georgia as well. That includes the Birmingham area down to Montgomery, east to Columbus, up to Atlanta, all the way through eastern Tennessee, just to the east of the Nashville area. And the tornado probabilities, once again, are robust. You can see the 10% tornado probability area almost nosing up into southern sections of Atlanta. Columbus area, just to the east of where I'm located right now, is where those storms could initially develop. Columbus off towards Savannah. And notice how that 10% area includes the Savannah River Valley once again. You have to wonder, with a bit of a modest low-level jet, if you're going to be able to funnel some of those surface winds more out of a southeasterly direction up the Savannah River Valley, similar to what happened yesterday with that mode of supercell storms that developed just ahead of the precipitation shield, some renegade supercells, classic supercells, definitely not HP at all. Well-ventilated updrafts, basically a wedge with hardly even a sheet of a rain curtain rotating around it. Obviously well-ventilated supercells, deep layer wind shear, deep layer outflow, low-level storm relative inflow certainly contributes to that. And definitely a classic year 2 La Nina, cold PDO, warm NPO blob across the north central Pacific. We've been documenting it basically this entire year. And this, though, is quite a complex trough ejection today. Here you can see the trough diving a main area, a large-scale trough replacing the ridge that has dominated the southeastern U.S. We have a little bit of a ribbon of flow as well across the northern Gulf of Mexico. That could contribute to a little bit of a pop in the low-level jet down into the southern region. That's why there's that 10% tornado probability zone across central Georgia, right near the Columbus area. This is the NAM forecast 0 to 3 kilometer EHI, or the Energy Helicity Index. That's a composite index that factors in surface-based instability as well as 0 to 3 kilometer SRH. I basically use this as a tool to kind of pick where, in general, the greatest surface-based instability is going to be co-located with the strongest low-level wind shear. This is the NAM model. We're going to start off with the NAM models, and then we're going to, of course, go over to the HRRR model. This is the 850 winds. These are basically about a kilometer up above the ground. You really need at least 20 to 30 knots a kilometer up to generate a tornado threat. You definitely will need low-level wind shear as well, low-level directional shear, low-level southerlies and southeasterlies. But you can see this greater 1 kilometer flow nosing into west central Georgia, nosing right up into the Columbus area by peak heating. That's at 21Z or about 4 p.m. Looking at the high resolution NAM, you can kind of see a general maxima in the low-level winds nosing up into southwestern Georgia. But there are vast differences between the NAM models and the HRRR, the short-range convective allowing models, and the abundance of convection that does form. Looking out the window right now, there is a lot of cloud cover across southeastern Alabama. That includes the Montgomery area. But the 3 kilometer NAM definitely shows widely scattered storms. You also have a band of convection that develops along the main cold front. That's going to be across northern Alabama. That's also going to convect. Likely will develop some supercell storms. The 3 kilometer NAM is picking up on these convergent bands. One across central Alabama, one across central southern Georgia. Also a southwestern Georgia mode of renegades that could develop right in the heart of the low-level jet down there as well, just along the southern edge. Really, this zone is the most prime zone for tornado potential, and that's why you have the 10% tornado zone. Looking at the storm relative helicity, 0 to 1 kilometer storm relative helicity. Relatively modest, about a 150 to 200. The 200 is in yellow. The lighter blue is definitely marginally favorable for tornado potential, but there is quite a bit of directional shear also. And notice as we go toward about 5 p.m., you start to get a blossoming of that low-level shear. Notice off to the east, though, up the Savannah River Valley, you're not seeing an increase yet by 5 to 6 p.m., 6 p.m. Eastern Daylight Time yet across the Savannah River Valley. That would suggest maybe a little bit further west would be an ideal target. But notice this strong low-level wind shear up across northeastern Georgia into upstate South Carolina, upstate North Carolina as well. That's likely co-located with a little bit less in the way of surface-based instability. And you can kind of see that's right along the northeastern nose of the instability up there across northern Georgia. Quite a complicated setup. You have a maximum in Cape across central Alabama, but a little bit less wind shear. You have these renegades that are going to be developing near the 10% area in Georgia with a little bit greater low-level wind shear. But you also have low-level wind shear across northeastern Georgia into upstate South Carolina as well. My mom and Gizmo are going to have to keep a close eye on these storms. She said that she's got her vehicle gassed up just in case she needs to go a little bit south to escape some of those storms. It looks like there is going to be a bit of a wedge of stable air just immediately to the east of the southern Appalachians that could protect upstate South Carolina and North Carolina and the Piedmont. But anywhere to the west of those Appalachians, northern Georgia, back even into east central Alabama, look at that 0 to 1 kilometer EHI. That's at 6 p.m., just blossoming across all of northern Georgia, up into eastern Tennessee as well. Definitely looking at trends in the models. Notice how those colors are getting brighter with time. And they're focused right over the Atlanta area. So at least according to the 3 kilometer NAM, which really doesn't form that blob of convection further south across central Georgia, it really lights up northern Georgia with quite a favorable environment for tornadoes. Looking at a forecast sounding. These photographs, even though they're not those dramatic photographs with a 60 to 70 knot 1 kilometer wind, they're still supportive of a tornado threat, especially with these due easterly storm motions at about 30 knots. You're able to squeeze out quite a bit of storm relative helicity near 300 0 to 1 kilometer shear and abundance of surface-based instability as well with that dramatic mid-level dry slot or elevated mixed layer coming in just above the ground. That's going to be the story this entire season, similar to 2011, 11 years ago. The dry slot at the mid-levels of the atmosphere punching in over top that heat and moisture at the surface, low 70s temperatures, dew points in the upper 60s to near 70 as well. Then you go into southwestern Georgia. Let's look at the forecast photographs in that mode. Real similar, a little bit greater dew points as well at the low levels, but really similar shear profiles from northern Georgia all the way down into the southwestern portion of the state. Low-level jet maybe not quite as strong. And keep in mind, this is all according to the 3-kilometer NAM. You go over to the HRRR and wow, what a difference a model makes. HRRR has this massive stable layer dominating northern Georgia, including the Atlanta area, a large swath of South Carolina as well. That definitely would be more of a saving grace for northern Georgia potentially. But at 20Z, before all the storms erupt, you can still see a belt of surface space instability across Atlanta. Looking outside right now, I can see quite a bit of cloud cover, so I do wonder if the 3-kilometer NAM is just overdoing the elevated mix layer a bit. That would help to carve out some of these storms. It wouldn't be as messy, less of a cluster. But the development of this cluster by the early afternoon would help to solidify the stable air across northern Georgia. There'd be a lot of cloud cover associated with that. You really wouldn't blossom the Cape like the 3-kilometer NAM is showing. I should note that the HRRR was accurate yesterday in the speed of that system arriving across southeastern Alabama by the late morning. The 3-kilometer NAM was a little bit slower with that trough ejection yesterday, so that's definitely important to note. But look at this blob formation. Columbus, Georgia, south side of Atlanta. I do think that the only chance of carving out a tornado here would be to work the southern portion of that blob. You can also see this prefrontal confluence band that convects across central Alabama with tornadoes. Look at these renegades across southeastern Georgia. You don't want to botch it up again yesterday, and you might want to work a funneling of a surface wind up through the Savannah River Valley. But you look at the 850 winds, and it's just northeast of the maxima in the low-level jet. You can see the low-level jet is maximized basically across southwestern Georgia, feeding into the southern edge of that complex of storms. This is at 5 to 6 p.m. Central to Eastern Daylight Time. But just northeast of that low-level jet, it does arrive, though, by about 6 p.m., a little stronger flow overspreading the Savannah River Valley. I do wonder if there is going to be a little bit of some funneling of southeasterly surface winds up the Savannah River Valley as well. Looks like the HRRR does hint at that a bit. You can see a couple of those barbs out of the due southeast. The terrain definitely matters today. We're going to be factoring that in here at Team Dominator. I do think that the low-level jet also gets consolidated around the Florida Big Bend region. That's why you get this maximum in this low-level jet funneling basically to the left of the Florida Big Bend. Basically this concavity within the shoreline helping to focus the low-level jet across the Florida Panhandle and into southwestern Georgia. That's why we get such strong low-level flow, I believe, as well. Look at this westerly bore that develops in the backside of that complex of storms. And it looks like by 0Z at 7 p.m., the same area that was impacted by those strong tornadoes yesterday looks a little bit more messy into the Savannah River Valley, but I do think you're going to get some southeasterly winds pumping up that area as well. That's why you have that 10% zone that noses into southeastern South Carolina. That's at 0Z, 7 to 8 p.m. Eastern Daylight Time. That's when those renegades are really starting to mature with the southeasterlies funneling up the river valley. This band convects as well. That includes the I-20 corridor, Tuscaloosa, Birmingham. Even those do have some tornado potential as well. Here's the 0 to 1 kilometer EHIs, and you could definitely see a pretty favorable Cape shear space, low-level shear as well, even back into Montgomery up toward Tuscaloosa, the I-20 corridor, central southern Alabama, along the southern periphery of that complex, the stable air from the blob of storms as well. You could certainly see how the terrain focuses the low-level jet and the enhanced low-level shear off the Florida Big Bend, just to the west of the Big Bend, funneling into south central Georgia. I think that that's the clue that we need to play. Basically from Columbus to Macon Look at the 0 to 1 kilometer EHI pop right into the Columbus area, and that's also right into the southern edge of that blob of convection that develops Montgomery, Columbus, eventually over to Macon. This is about 5 p.m. Central Standard Time, Central Daylight Time. And that's going to be our chase. And then you start to get a favorable uptick in the low-level shear surface-based Cape environment along the Savannah River Valley as well. But what a difference between the HRRR model and the 3-kilometer NAM. The 3-kilometer NAM invigorates the surface-based instability and the low-level shear space across northern Georgia. I think if you play the Columbus area here, though, you can kind of play both of these models. You could play the southern mode, you could play the northern mode, and keep both in play until the afternoon arrives, and then you can see which model was correct. Well, the 3-kilometer NAM would say head a little bit north, play the southwest side of Atlanta, most favorable low-level shear and instability space, whereas the HRRR model says play the southern edge of the blob, Columbus area, southeastern Alabama, work the outflow boundary that might also set up here as well. Let's look at a surface map. Real observations are very important. And the real observations, the surface map so far would certainly support kind of an HRRR type of a solution. You can see an abundance of cloud cover, basically those 3 lines over top of each other. That shows fog, stratiform clouds. I'm in the Montgomery area. Back here you can see cloud cover dominating. Look at all these, the two lines there, 2 and 3 straight lines. That shows fog, stratiform cloud, drizzle as well. And you can definitely see a differential heating boundary that's setting up. It is going to be lifting off to the north. It's definitely through Eufaula, Alabama now as temperatures are starting to warm up. You should see some holes in the cloud cover as well. Dew points down into the low to mid 70s across the Florida Panhandle into southeastern Alabama, southwestern Georgia, southwesterly winds. So this boundary should gradually lift off to the north, and likely the HRRR is picking up on this boundary being the focus for convective initiation, blob formation, work the southern edge of that blob as it progresses off to the east. Some veered surface winds up the Savannah River. If you had those height falls that would be arriving from the west, like yesterday's intensifying upper level storm system, that could pull in some southeasterly surface winds up the Savannah River Valley. Southwesterly winds at 40 knots over top of that would maximize the low level shear out there. But I think we're going to have to play the Florida Big Bend convergence zone. Low level jet getting funneled up the western edge of the Big Bend and into southwestern Georgia. I do also want to go over the hodograph plots a little bit, grid point by grid point hodographs. But first we want to look at the satellite imagery, very important tool that we use as storm chasers. Most of us at least. These are real observations looking at the cloud cover. Visible satellite. So here's what I can see. I can see an abundance breaks in the clouds here across southeastern Alabama, nosing into southwestern Georgia. I can also see some tops of some elevated convection up into the south side of Atlanta. That's likely going to impede the development of surface space instability. I can see a bore surging off to the southeast ahead of the main cold front as well. Gravity waves back behind it, suggesting that there's definitely stable air behind that bore. You can see the wave-like configuration back behind there, like waves on top of a stable layer, waves on top of an ocean. But you can definitely see surface space instability bubbling across southern Alabama. You can certainly see a reinforcement of the outflow boundary or differential heating boundary into central and southern Georgia. Some tops of the elevated convection reinvigorating across that zone as well. But look at that bore dropping off to the southeast. Wow. Probably a beautiful mega shelf visible with that. There's our old storm system ejecting over the Gulf Stream. Going to see a hint at some stable air to the east of the Appalachians. Let's look at the RAP model, coupled with our peek at the surface map and satellite imagery. And let's see where the surface space instability is located so far today. Wow. A ton of CAPE, a very large warm sector today, setting the stage for a complicated forecast and storm chase. But you can definitely see an abundance of surface-based instability building beneath the low-level clouds. This is the stable layer here in Montgomery, and it's about to erode along the southwest and southern edge. We're about to see cloud breaks in the clouds definitely appear as we go through the day. Wind shear relatively modest, I would bet, as the low-level jet still has yet to increase, focused mostly where the low-level stable layer is located. Let's forecast out with time. Let's go toward 20Z. And it looks like the RAP model also is on board with the blob formation that the HRRR shows from east central Alabama into southwestern Georgia. And it looks like we're going to have to play the southern periphery of that blob. Columbus down toward Albany, and then areas off to the east. Notice how by 20Z you don't see a blow up of the low-level wind shear across the Savannah River Valley between Georgia and South Carolina as much. But definitely see that modest low-level wind shear beginning to maximize across the southern mobile. Look at that blob formation. That's why it looks like the 3-kilometer NAM and the NAM models do not have a good handle on the development of that big instability into northern Georgia and east central Alabama. The blob formation should impede that. Clouds, an abundance of clouds should also impede the development of the surface-based instability into northern Georgia. But this is definitely a tough forecast. Look at the significant tornado parameter. That's just going to be a current look. I think it'd be more important for us to look at the hodograph project or hodograph product on pivotal weather by the HRRR model, which seems to have the best handle on the blob formation. So we're going to use the hodograph product where each grid point displays a hodograph, and then we'll also do a forecast out using the 13Z HRRR. Let's use a forecast out at 21Z and try to see where the best hodograph shape is located and overlap on the surface-based instability. This is surface-based CAPE, HRRR, surface-based CAPE, forecast at 21Z. With the hodograph plotted at every grid point. Looks like straight line hodographs across central Alabama along the I-20 corridor will really limit the ability for the right moving supercells to dominate, will really mitigate the tornado potential. But you could definitely see this boundary that sags down from basically the Montgomery, Alabama area through Columbus out toward Macon. Notice how the hodographs are a little bit flat at 21Z up the Savannah River Valley, but just to the east of there, you have a nicely curved hodograph. Kind of reduced low-level shear, but it is nicely curved across southeastern South Carolina. Larger curvature across south-central Georgia between Columbus and Macon. A little bit greater low-level wind shear available to those. A little bit longer of a purple vector. Your 0 to 1 kilometer shear vector is a little bit longer there on that hodograph. Longer purple shear vector, and even some decent low-level wind shear further west near the Georgia-Alabama border by 21Z. But really you want to be on that storm. You can even see a little bit of a divot within the differential heating boundary, and that storm is just ahead of that little trough in the differential heating boundary. So I believe that that's the storm we want to be on. Columbus toward Macon, south edge of that blob of storms that definitely carves out the instability. It does try to build in some surface instability to the north of the blob across Atlanta, but not as favorable hodographs to the north of the blob, as it will impede the low-level jet. The low-level jet's just going to slam into that blob of stable air and really maximize here across southwestern Georgia. That's the 10% area. Skinny hodographs, though, across central Alabama behind the blob, even though you get a reinvigoration of the CAPE and surface-based instability with that one. So that's our plan of attack today. We're going to do a bit of a slow pickle off to the east toward Columbus. We're going to be at full-blown storm chase mode. We're going to try to deploy the gravity wave sensors again, this time in a triangle configuration. We were able to deploy a line. We managed a line with about 0.5 kilometer spacing ahead of the storm. I was trying to maximize the likelihood of getting a direct hit with one of the gravity wave sensors by the tornado, and I wasn't sure if it was going to make that hard left-hand turn. Mark's going to be upset that it wasn't in a triangle configuration. He was already having the publication ready to go. But notice how up here ahead of the blob, you definitely get the surface space instability into southeastern South Carolina, and definitely some nice compact photographs that if you get some small renegades that develop again, southeastern Georgia into southeastern South Carolina, those are going to have potential once again, but that's going to be a later threat. And look at those supercells evolving into that eastern South Carolina target once again. Photographs start to pinch off across southwestern Georgia with time as you get towards 6 p.m. We're going to want to be in this environment near Macon, with a storm interacting with that differential heating boundary or outflow boundary from yesterday. Storms develop in the wake of that as well. But another enhanced risk, the third in a row. And don't forget, a historic trough ejection still expected next week. That's going to be around April 13. Tornado Alley is going to come alive like it has not in years, probably since 2019, with that mega trough ejection, a huge, large-scale, low-level jet. Traditional Tornado Alley, Texas, Oklahoma, Kansas, Nebraska. And it looks like that setup's going to happen. So stay tuned on that, but we got to get through today. Got to take one day at a time. That's important. That's hard to do as an extreme meteorologist. But very happy that our gravitron sensor survived being deployed. Yesterday, a stop sign was flattened right next to the gravity wave sensor. We saw a lot of damage to a church, including the roof to that church, but very excited to look at the results that Mark has. So thank you, everybody. Thank you, Facebook subscribers as well. Be sure to join our community. I am going to be doing an exclusive breakdown of the data that we collected yesterday with the gravity wave sensors provided exclusively for Facebook subscribers. Look forward to discussing that data. We'll do a whole exclusive live Q&A around that data as well, discuss what it means, the pressure falls, what are gravity waves, the temperature and the relative humidity data that we collected from those gravity wave sensors as well. So thank you, everybody, for tuning in. I hope you enjoy my weather reports. We're going to be going live as we get a little bit closer to midday into the early afternoon. Brian and I, once again, are going to be out in the field streaming live, trying to intercept these tornadoes, deploy gravity wave sensors, and dominate. Never stop chasing.